Alright, so we have some brand new problems. Find the length of x to the nearest whole unit. Now you'll notice this isn't just one triangle anymore, so we've got more work to do here, but we're going to combine the ideas that we used for part 1 of this video to solve basic simple triangles and put that information together to find this length of x. And so notice we have two right triangles going on. We've got the one noted right here, okay? So again, I could highlight that for you. Here's one right triangle, okay? And on the other hand, we have a second right triangle right here, all right? And let's think about those as two separate right triangles, okay? And we could even redraw them, all right? So the top one, if I redraw that, I'm just going to kind of pick it up and put it on its side right here, okay? Then we know that this is the 100 length right here. We don't know this side over here. We don't need to know it. We need to know how long that is, right? And then we know up here is 20 degrees. And it may be easier for you to just look at this picture right here probably than look at this picture down here. But that's the length we need to find, okay? On the other hand, we look at the second triangle, and this is the length that we need to find. And then if we add those two lengths together, that's going to give us, let's get rid of this triangle down here, that's going to give us what we need, okay? So now let's go back and work on these triangles. So first let's work on the green triangle. The side that we're looking for compared to the 20 degrees is the opposite side, right? So we're looking for opposite over there. The side that we know is the adjacent side. The hypotenuse over here, we don't know it, we don't need it. So I'm not going to use a trig function that involves hypotenuse whatsoever. But what trig function involves opposite and adjacent? And you know that's tangent. So I'm going to say the tangent of 20 degrees is equal to opposite. Now, we can call that anything you want. You can call it opposite, but I'm just going to call it, say, x1 over adjacent, which is 100. Now, I'm trying to solve for this x1, okay? And again, calling it x1. So I'm going to multiply both sides by 100. So by 100 over here, by 100 over here. And I'm going to type that in my calculator. Again, make sure you're in degree mode. I'm checking one good time, and I am. So I have 100 times the tangent of 20 degrees, and that gives me 36.397. I'm going to go ahead and take that out several decimal places. In the end, it's not necessary that it goes out that far, but I want to make sure that we go past what it asks for. So 36.397. Now let's work with our blue triangle. Okay, so I'm going to call this distance that we're looking for, let's call it x2 for triangle 2. Notice we have an angle of 8 degrees. The side across from the 8 degrees is called opposite, so we're working with opposite again. Okay, the angle adjacent is the 100, so once again adjacent is 100. The hypotenuse is this angle across the bottom here because it's across from the 90-degree angle. We don't need it, we don't know it, we don't need it, it's not important. So again, what trig function involves opposite and adjacent? Well, the same one we've already used. So I know this time that tangent of 8 degrees is equal to the opposite. We called that x2 for that side length over the adjacent, which is 100. I'm going to do the math and multiply both of these sides of the equation by 100. Okay, so that'll cancel. So now I have 100 times the tangent of 8 degrees is x2. So typing that in my calculator, so 100 times the tangent of 8 degrees, and I get 14.054. Okay, now remember, we're adding these two values together. So these two added together gives me 50.451. But now it says round to the nearest whole unit, so that's going to be 50 units. And that's how long this whole entire X is. So basically when you see these problems, you must come up with a plan. So spend some time breaking it down. If you have to draw it into two separate triangles so you can really see what's going on, do. I abandoned that step in this case because I thought it was easier just to look at the figure they gave us. But you have to develop a plan. You're not always adding. Sometimes you're subtracting. Sometimes you're setting up a ratio. So let's continue on and see what other kind of problem we can find. All right, so let's take a long look at this problem. I'm seeing a few different triangles in here. I'm seeing the overall big triangle. This is a right triangle for sure. Okay, so we can use our techniques on that triangle. But notice inside, we're not dealing with a right triangle, folks. Okay, so this triangle right here, if I shaded it in all yellow, you can't talk about it by itself, yet they want to know the length of that base of that triangle. And we can't do it just using that triangle. But we do have two separate right triangles that we can discuss. If we take this apart, let's see if we can draw these two different right triangles. So I've got this smaller one in green, and again I'd already outlined the bigger one in yellow. You see that? And again, if you need to draw them separately, do. So the smaller one in green, okay, and that is 64 degrees, and this length is 300, whereas you have a bigger one in yellow. Okay, we know that's 34 degrees. That's still 300. And what would the plan be? Okay, well, we could call this whole length down here x2 and this length right here x1. What would just x be? If this whole length is x2 and then this little green part here is x1, then x would actually be, if we subtract x2 minus x1. So that's our plan. We want to find this whole length and subtract out the small green length using only these two right triangles, the small one and the big one. Okay, so let's work with the green one first. All right, now let's think about what all these sides would be labeled. If this is 64 degrees, this 300 would be opposite. Okay, this is hypotenuse. We don't need it for anything. And then this is adjacent. What we're looking for is adjacent. So what's a trig function with opposite and adjacent? Well, tangent's the winner, right? So we could say tangent of 64 degrees is equal to opposite, which is 300, divided by adjacent, we're calling x1. Now to solve this equation, I need to multiply both sides by x1, because I cannot solve with my x in the denominator. Okay, so my next step is rewrite x1 times the tangent of 64 degrees is equal to 300. Remember, I'm trying to solve for x1, so I'm going to have x1 is 300 divided by the tangent of 64 degrees. And then I type that in my calculator in degree mode. So 300 divided by the tangent of 64 degrees gives me 146.32. I had to round there. I was going to take it out 3 places, but it was easier to take it out 2 places. Okay? Now, let's work with yellow. So in the green, this is what I found. This length is 146.32. Now the yellow includes this length, so from here to here is 146.32, but we're going to find the whole distance, okay? Now compared to 34 degrees, 300 is opposite. I don't need the hypotenuse. I don't know the hypotenuse. And x2 is adjacent. So again, I need a trig function with opposite and adjacent. Tangent's the winner. So I have tangent of 34 degrees is equal to opposite, which is 300 over adjacent, we're calling x2. Again, since the variable I'm trying to solve for is in the denominator, I need to multiply both sides of this equation by x2, so those will cancel. That gives me x2 times the tangent of 34 degrees is equal to 300. I'm going to divide both sides by the tangent of 34. So x2 is 300 divided by the tangent of 34 degrees. And then that typed in my calculator. So 300 divided by the tangent of 34 gives me 444.77. Alright, now remember the plan is to type the long one, which is the yellow one, 444.77, minus the shorter one, which is the green one, 146.32. Subtract those, and that gives me a final answer of 298.45. And it says to the nearest whole unit, well, that would be 298. So that's my final result, 298. All right, so we have another solve the right triangle. Notice we have two triangles going on here. You got to absorb a minute, take it in, see what we're looking at. We know that this length right here is 400, but that does not belong to a right triangle. Okay, so our trig ratios, our definitions for sine and cosine and tangent, only are going to apply to the right triangles that we're dealing with. And so we've got a little bit of an issue here. We're trying to find x. Okay, so let's take a look at what's going on. Now, I've got this big triangle right here. So in purple, I have, compared to 20 degrees, my opposite side is x. My adjacent side down here, okay, that's just adjacent. All right, I don't know the length. I know part of it's 400, but I don't know the length. Okay, and then we have another triangle in here. This guy right here, okay, our smaller triangle. Now it also has an opposite side of x and an adjacent side of whatever minus the 400 down here that's going to give us that total. So this is a little different. We need to set up a ratio. Okay, so let's draw our two separate triangles. I'm going to draw them outside of our picture. So I've got the big purple triangle. I know part of this is 400. How about we call this part x? So all the way across the bottom is going to be 400 plus, better yet, let's don't call it x. You know why? Because we already have an x over here that we're looking for. Let me back up here. Let's not call that x. Let's call it a. And why is my eraser not working? There we go. Okay, so we're going to call this a. So this is 400 plus a across my big purple triangle. This is 20 degrees, and this is x. And then I have a smaller orange triangle. Okay, so a is what we call the bottom. This is 40 degrees, and that is the same x as this is over here. So it's not like x1, x2. This is the same height on both of these triangles. Okay, now the goal really is going to be, because we're trying to solve for x, is set x's equal. That's going to be our goal. So let's set this purple up as a trig function. So I've got across this way, you agree, that's opposite. This way is adjacent. The problem is we don't know either one of them. But let's just set it up. So I can say what trig function has opposite and adjacent in it? Well, that is tangent. So I have the tangent of 20 degrees is equal to opposite, which is x, over adjacent, which is 400 plus a. Okay. Now, if I solve this for x, I'm going to multiply both sides by 400 plus a. So I'm going to have 400 plus a times the tangent of 20 degrees is x. Now, for my orange over here, all right, I'm going to set up again. So across from 40 degrees is opposite. Next to the 40 degrees is adjacent. Okay, so opposite and adjacent is still tangent. I have tangent of 40 degrees is equal to x over a. Now I solve this equation for x and I multiply both sides by a, so I have a times the tangent of 40 degrees is equal to x. Now we're going to get the x's equal to each other. So I'm going to set this x equal to this x, which really means, folks, we have an equation that says, let's do this in black, 400 plus a times the tangent of 20 degrees is equal to a times the tangent of 40 degrees. Now if you wanted to, you could go ahead and get the decimal version of the tangent of 20 and the tangent of 40 and work with decimals. I tend to wait till the very end to plug this in my calculator. So what I need to do instead is use the distributive property. I'm going to multiply this tangent of 20 inside. So I have 400 times the tangent of 20 degrees plus a times the tangent of 20 degrees is equal to a times the tangent of 40 degrees. Now remember what our overall goal is. Our goal excuse me please, is to solve for a. You notice this term has an a in it and this term has an a in it. This term doesn't. So how about I move this term to this side of the equation, okay, and that way all my a's are on one side and my non-a value, this first guy, stays on the left side. So I'm going to open up a new page for you, okay, and continue this process. Well, my new page isn't opening up. How about we just erase some of this up here as I lose my voice. All right, so let's get rid of the triangles. We need triangle space right here, okay? All right, our goal is still the same. But I'm just going to go up here and eliminate my two separate pictures. We don't need that anymore. So I'm starting back with the black. I have on the left, I'm keeping this first term on the left, 400 times the tangent of 20 degrees equals, on the right, I already have a tangent of 40. Now I'm subtracting a tangent of 20. Okay, now notice these both have an a in it. I'm going to factor out that common a. So now I have 400 times the tangent of 20 degrees is equal to a times the tangent of 40 minus the tangent of 20. Notice what I did? I just factored out the greatest common factor. So I factored that guy out front right here. Okay, now I'm trying to get that a by itself, so what am I going to do? I'm going to divide both sides by the tangent of 40 minus the tangent of 20. So that's going to come over here, tangent of 40 minus tangent of 20. And no, that's not tangent of 20. You can't just subtract those. You have to type all of this in your calculator with parentheses right here. Going to give you 306.418 if I round 3 decimal places. So when you type that in your calculator, again, be careful. That's 400 times the tangent of 20 divided by, you definitely need these parentheses, the tangent of 40 minus the tangent of 20. Now that's a. Okay, so keep in mind that's a. That's not our final answer. That's just this value. Remember, what we're trying to find is x right over here. We're trying to find that height. So now what in the world are we going to do? Well, if you'll look at your equations in orange over here, I've got it already circled. A times the tangent of 40 is x. Okay, so I know a now. So I can set that up as 306.418 times the tangent of 40, and that's going to be my x value. So I'm going to type that directly in. So 306.418 times the tangent of 40 degrees, and I got 257.115, or x is equal to 257. And that's our final result for x.